If you've ever, say, booked a flight on your phone or maybe checked your bank balance in an app.
Or even just had your medical records sent from one doctor to another.
Exactly. You have, whether you knew it or not, relied on something called an API, an application programming interface.
Right. They're basically the invisible plumbing of the entire digital economy. They're absolutely critical.
You really are. They're the secure gateways that connects the app on your phone to the massive bank vault of data on the other end.
And they're more than just pipes for data. They're the control points. They decide who gets access to what and when. It's all about security.
It is, which is precisely why when that supposedly secure plumbing breaks, and I mean when the core security fails, the results can be, well, catastrophic.
And that's what we were talking about today, a major break.
A huge one. Today, we are deep diving into a digital alarm bell that is ringing incredibly loud across the entire enterprise software world.
We're looking at a security bulletin, a really severe one, about a fundamental flaw that was just disclosed in IBM API Connect.
The vulnerability is tracked as CVE-2025-13915. And here it is. This is the part that should give everyone pause. The severity rating is a 9.8 out of 10.
A 9.8.
Wow. Okay, let's just unpack that for a second. A 9.8 is basically the highest possible alarm. A perfect 10 is almost theoretical. It often requires, laboratory conditions.
So 9.8 is as bad as it gets in the real world.
And the timing here is just, it's so critical. This bulletin came out on December 31st, 2026. This isn't ancient history. This is an immediate active threat.
Right. Companies are scrambling to patch right now.
So our mission for you today is to give you all the context you need to really understand this crisis. We're going to break down what API Connect even is.
And why this flaw, an authentication bypass, is so devastating.
We'll explain what that 9.8 score actually means, piece by piece. We'll even name the specific huge corporations that are affected.
And then, most importantly, we'll get into the fixes. The permanent patch, but also the critical workaround IBM provided.
You need to know not just how bad this is, but exactly what the technical steps are to stop it. Let's start with that number because it's just terrifying, 9.8. To a lot of people, that's just a high number. But in the security world, it describes a very specific, almost perfectly weaponizable scenario.
It really does.
So what does that score truly imply? What are the specific ingredients in the CVSS framework that push a vulnerability into this critical category?
That's exactly the right question. The CVSS, the Common Vulnerability Scoring System, it's all about creating an objective score based on specific metrics. And a 9.8, that's a perfect storm of the worst possible ratings on the exploitability side.
Okay, so let's break those down. What's the first ingredient in this recipe for disaster?
First up is the attack vector. And for 9.8, the attack vector, or AVE, has to be network.
Network, meaning?
Meaning the attacker can be anywhere in the world. They don't need to be in the building. They don't need to be on the local Wi-Fi.
You just need an internet connection.
Exactly. They can launch the exploit remotely from thousands of miles away against any vulnerable IBM API Connect instance that's exposed to the web. That global reach is the first piece of the puzzle.
So it's reachable from anywhere. What about how hard it is to actually pull off the attack? That gets us to attack complexity, right?
Right. Attack complexity, or AC. And for a 9.8, the complexity has to be low.
Low, so it's easy.
It's very easy. Means you don't need specialized knowledge, you don't need supercomputers, you don't need to get the timing just right.
It's not like a movie heist.
Not at all. It means once someone writes the exploit code, and they will, it can be automated, put into a script, and then anyone, even low-skill attackers, can just press a button and launch it against thousands of targets at once.
Okay, so remote access, and it's easy to do. That's already a nightmare scenario. But what about, does the attacker need to have some kind of foothold first, like a stolen password? That's the privileges required metric.
And that's the real kicker.
Yeah.
For a 9.8, privileges required, or PR, must be none. None. Zero. This is what makes it an authentication bypass. The attacker doesn't have a username, they don't have a password, no API key. They are a complete anonymous stranger to the system.
And the system lets them in anyway.
It's like the front door doesn't even bother to ask for a key. It just swings open.
Wow. Okay, and the last piece of this is user interaction.
User interaction, or UI, also has to be none.
And what does that mean in practical terms?
It means the attacker doesn't need to trick anyone. They don't have to send a phishing email to an employee or get someone to click a bad link.
So no human on the victim side needs to make a mistake.
Correct. The attack is completely self-contained. The attacker launches their code, the system breaks. No one on the inside even knows it's happening until it's too late.
So if you put all four of those together, network vector, low complexity, no privileges, no user interaction, that's the definition of a wormable flaw, isn't it?
It is. It's a recipe for a global, automated cyber attack that can spread from machine to machine on its own. And the impact metrics just seal the deal. For it to be a 9.8, the impact on confidentiality, integrity, and availability must all be high.
Meaning the attacker can steal data, change data, and shut the whole system down.
Everything. They get the keys to the kingdom. That's what a 9.8 really means.
So now we understand the why behind the score. Let's dig into the what. This is where it gets really interesting for me. What does it actually mean to bypass authentication on a system that is itself supposed to be the security guard?
It's a fundamental contradiction, isn't it? Authentication is, it's the bouncer at the club door checking your ID.
Right.
An authentication bypass means the attacker has found a way to just stroll right past the bouncer, or maybe more accurately, they've tricked the system into thinking it already checked their ID, even though it never did.
So they're not picking the lock, they're exploiting some forgotten key under the digital doormat.
Exactly. And in the context of API Connect, this means the attacker gets access to the application itself, the main control panel.
IBM's official description is pretty blunt. It says, a remote attacker could gain unauthorized access to the application. The emphasis is on the whole application.
And that's critical.
Yeah.
We have to think about what this application is. API Connect is the central brain for all the other APIs. If you get into that management console, you don't just compromise one thing. You could potentially...
Do what?
Well, for one, you can steal all the master API keys for every service the company uses.
Oh, wow.
You could rewrite the security rules. Turn off rate limiting, for example, so you can just hammer a database without anyone noticing. Or just disable security checks entirely on, say, a financial transaction API.
You could just open the floodgates.
You are the floodgate. You control it. In a system with multiple customers, you might even be able to jump from one client's environment to another's.
So it's not just that the security guard is asleep. He's handed over the master keys to the entire building. This is a complete failure of the system's core promise.
It's a foundational failure. And it's often an issue with something called identity assertion. The system has to sort of stamp a user as valid at some point. An attacker finds a way to trick the system into applying that stamp before it ever actually checks for a password.
And once they're in, they look just like an administrator.
Just like one. The system trusts them completely.
Okay, this abstract threat has to translate into a concrete to-do list for IT teams. And that means knowing, with absolute certainty, if the version they're running is vulnerable.
This is priority one for any CISO right now. Every minute of uncertainty is a minute of extreme risk. They are running scans across their entire infrastructure as we speak, looking for these specific versions.
And the source material is very, very precise here.
It have to be. The bulletin lists two specific ranges. The first is version 10.0.8.0 all the way through 10.0.8.5.
Okay, the whole 10.0.8 branch.
Right. And the second one is a point release, version 10.0.1.0.
That's interesting. It's not a sequential block. It's one branch, and then it jumps to a later version.
It is. And that tells us something, though we can't be 100% sure. It suggests the vulnerable piece of code is pretty fundamental, something that was present in the 10.0.8 stream.
And then somehow got carried over, reintroduced in 10.0.11, even if it was fixed in, say, 10.0.9 or 10.0.1.
Exactly. It's a classic enterprise software maintenance headache. And for an administrator, this specificity is everything. If you're running 10.0.7, you can breathe a little easier, but if you're on 10.0.8.3...
You're in the blast radius.
You are square in the middle of it. And you have to remember, large companies are often very slow to upgrade. They value stability. So it's extremely likely that a huge number of major institutions are still running something in that 10.0.8 range.
Which makes the vulnerable install base massive.
It does. And administrators need to check their asset databases, check their deployment manifests, and confirm their exact version number against that bulletin, like yesterday.
Okay, that sets the technical stage. Now, let's talk about who is in that blast radius. Who is using this software? So we've established how bad the flaw is. A 9.8 remote auth bypass. Now let's talk about the product itself. Why is IBM API Connect so common? And why is a flaw in it a systemic threat, not just, a bug in some random app?
Well, API Connect is really a cornerstone technology for any large company that's serious about its digital presence, especially in regulated industries like finance. IBM calls it an end-to-end solution.
And what does end-to-end actually mean in this context?
It means it handles the entire life cycle of an API,
Yeah.
from the moment a developer starts building it, to testing it, to managing different versions, and finally to securing it in production.
So it does more than just route traffic.
Oh, much more. It's a central policy and security brain. It's the thing that sits between the scary public internet and a company's crown jewels, the back-end systems.
The digital customs agent.
Perfect analogy. It inspects every single request coming in. It checks for security tokens. It protects against attacks. It makes sure no one is overwhelming the system with too much traffic.
And it handles the authentication, the very thing that's broken here.
Precisely. It's the police checkpoint, the traffic light, and the customs agent all rolled into one.
Oh.
And because it can be deployed anywhere, in a company's own data center, in a private cloud, on Amazon or Google's cloud, it's become ubiquitous.
So what's here is that if you compromise the control panel for API Connect,
You've compromised the very tool that is supposed to be protecting everything else. It's a total loss of trust in the entire security model. All the other defenses it provides become meaningless if an attacker can just waltz in and turn them off.
which brings us to the real-world users. This is
Yeah.
where the theoretical danger becomes very, very real. The sources name specific companies.
And that list it's deeply concerning. It reads like a who's who of global finance and critical infrastructure.
Let's start with the banks. We're talking about Axis Bank, State Bank of India, and Bankcard, which is a huge payment processor.
Right.
What does unauthorized admin access to the API gateway mean for a bank?
It's a nightmare scenario. It's not just about stealing data, though that's obviously possible. An attacker could do so much more.
Like what?
They could silently change the rules. For example, they could find the API that handles fund transfers and just disable the multi-factor authentication requirement for it.
Oh, no.
Or they could change the configurations to expose internal database credentials, letting them pivot deeper into the bank's network. Or they could just set up a quiet listener on the gateway itself, copying every single transaction, every customer detail that flows through it in real time.
It's a supervisor key to the flow of money for millions of people.
And billions of dollars.
Yeah.
Now let's pivot to aviation. The list names Etihad Airways.
Different industry, but the potential for chaos seems just as high.
Absolutely. APIs in an airline manage everything. Check-in, baggage handling, flight manifests, cargo.
So what's the worst case scenario there?
Pure operational disruption. Imagine an attacker gets in and just shuts down the APIs for the check-in systems across an entire airport.
Right before a major holiday.
Exactly. You'd have thousands of stranded passengers, grounded planes, massive financial loss, and a huge blow to their reputation. Not to mention the security implications of someone being able to tamper with passenger manifest data.
And then there's the last one on this list, which might be the most significant of all, Tata Consultancy Services, or TCS.
Yes, this is where the risk model changes completely.
Why? Because TCS isn't just one company. They're a service provider to hundreds of others.
Precisely. This is a supply chain risk. TCS uses API Connect to manage and secure the digital services they provide to their own massive client list. If the TCS instance of API Connect is compromised,
The attacker doesn't just get the keys to TCS.
they potentially get a master key that could unlock the doors to hundreds of other companies that trust TCS. They could pivot from the TCS environment into client environments. This is how a single vulnerability becomes a systemic global event.
And the other names mentioned, Phonology, IBS Bulgaria, TN, they just confirm this isn't a regional problem. It's a global one, affecting finance, tech, logistics.
The bottom line is the 9.8 score is not theoretical. It is sitting on the systems that manage our money, fly our planes, and run the backbone of the global IT industry. The stakes just couldn't be higher.
Okay, so given that insane level of risk, the only logical response is to patch immediately.
Immediately. IBM has been clear. The bulletin says users are advised to apply the fixes as soon as possible for optimal protection.
Right. And there is one small piece of good news in all this.
A very small piece, which is that as of the bulletin's release on December 31st, IBM said there was no evidence of this being exploited in the wild.
But that window, it feels paper thin. Why is it so critical to act before you see active attacks?
Because the moment a patch is released, the race is on. Security researchers, both the good guys and the bad guys, start doing the exact same thing.
Which is what?
They reverse engineer the patch, they take the new fixed code and compare it to the old, vulnerable code. That difference, the diff, points a giant flashing arrow directly at the line of code that was broken.
So the fix itself becomes a roadmap for building an exploit.
It's the best roadmap you could ask for. And for a flaw, this simple low complexity, no privileges, once you know where the hole is, writing the code to exploit it is trivial for a skilled attacker.
So you're in a race against time measured in hours or days, not weeks.
Exactly. Especially for a product like this that sits on the edge of the network facing the internet. Patching has to be the #1 priority above everything else.
But that's a huge challenge in big companies, isn't it? The patch is available, but you have change control boards, testing cycles.
It's a massive challenge. You've hit on a core problem in enterprise security. IBM provides the fix, but the organization has to actually deploy it. And that gap, that organizational lag between the patch being available and being deployed everywhere, that's the attacker's window of opportunity.
Which is why the workaround becomes so important.
It becomes absolutely essential.
So for the admins out there listening who are in the middle of this fire drill, let's get very specific. What are the exact steps to apply the fix?
The plan from IBM is a very clear, methodical 3-step process.
Okay, step 1.
Step 1 is to download the fix itself. You have to go to IBM's repository, which is called Fix Central. You can't just grab it from anywhere. You log in, find the specific iFix for this CVE, and make sure it matches your version.
Precision is key.
Yeah.
You can't apply a 10.0.8 patch to a 10.0.11 system.
Absolutely not. That could break things or just not work.
Yeah.
So step 2, once it's downloaded, is to extract the files.
And the bulletin names 2 specific files to look for.
It does. A readme.md file, which has the instructions, and the patch archive itself, which has a very specific name. IBM API Connect version ifix.13195.tar.gz.
Let's break that file name down, the iFix part.
Yeah.
That's important, right?
Very important. It needs interim fix. It's a small surgical patch. It's designed to fix only the security flaw and nothing else, to minimize the risk of it breaking some other feature.
And the number 13195.
That's the internal tracking number for this specific patch. It's the proof, for auditing purposes, that you've applied the correct fix for this critical vulnerability.
Okay, so download from Fix Central, extract the files. What's step 3?
Step 3 is to actually apply the fix, following the instructions in that README file to the letter. This will almost certainly involve taking the API Connect services offline temporarily, applying the patch, and then bringing them back up.
Which is why it requires a maintenance window. You can't just do it in the middle of the day.
Not in a production environment, no. Which leads us to the big question.
Yeah.
What do you do in the meantime while you're waiting for that maintenance window?
Exactly. For a global bank, you can't just take systems down on a whim. Even for a critical patch, it takes planning. So what was the temporary lifeline IBM offered?
This is, I think, the most fascinating part of the whole bulletin. IBM gave a very specific and very revealing mitigation strategy.
Okay, what was it?
They said, I'm quoting here, customers unable to install the interim fix should disable self-service sign-up on their developer portal if enabled.
Okay, stop there. That is incredibly specific. If the flaw is a general authentication bypass, why would disabling sign-up on the developer portal fix it?
This is the clue. This tells us almost everything we need to know about the attack vector.
How so?
Think about what the developer portal is. It's the public-facing front door. It's where external third-party developers, people you don't know and don't trust yet, come to register for an account to get API keys.
They are, by definition, unauthenticated users.
Exactly. They're the anonymous public. The fact that disabling their ability to sign up for a new account mitigates the vulnerability strongly suggests the flaw is located within that sign-up process.
So the attacker isn't attacking a login page for existing users. They're attacking the new account registration flow.
That seems to be the logical conclusion. The attack probably involves submitting some kind of malformed data during registration. A weird username, a specially crafted email address.
That tricks the system into thinking this new, unvetted user is actually a pre-existing privileged administrator.
Precisely. It could be an identity assertion flaw, or maybe a race condition in the code that creates the account. But the point is, the entry vector is the self-service sign-up form.
So by turning that feature off,
you seal that specific entry point, you shut the vulnerable door. Now, any new developer has to be provisioned manually by an internal admin. You've completely removed the ability for a remote anonymous attacker to trigger the flaw.
it's a tourniquet. It stops the bleeding and buys the organization the time it needs to schedule the surgery, which is applying the actual patch.
A perfect analogy. You're sacrificing a little convenience instant signups for total security. And when you're facing a 9.8, that's a trade you make every single time.
So we've gone from the abstract terror of a 9.8 score to the real-world impact on global companies, and finally, down to the specific command line fix. Let's try to synthesize the key takeaways for everyone listening.
I think it boils down to three absolutely critical facts you need to remember from
Go
this.
for it.
1. The score. CVSS 9.8. This means it's remote, it's easy, it requires no credentials and no user interaction. It's a full authentication bypass in the one system that's supposed to handle authentication.
2.
2. The scope. This isn't some niche product. It's IBM API Connect, used by critical infrastructure. We're talking major banks like State Bank of India, airlines like Etihad, and the massive supply chain risk from a company like TCS.
And number 3, the most important part.
The solution. You have to patch. You need to get iFix 13195 from Fix Central and apply it now. And if you absolutely cannot, your immediate non-negotiable action is to disable self-service sign-up on your developer portal.
So really, what does this all mean for the bigger picture? We started with a number, 9.8, and we've ended up with this snapshot of just how fragile the digital economy can be when these centralized systems fail.
It's a huge lesson in the danger of putting all your security eggs in one basket. The whole idea of these massive end-to-end platforms is that they simplify things, but they also create a single catastrophic point of failure.
And that leads us to our final provocative thought for you to take away from this deep dive, something to think about in terms of your own digital security.
And the question is this.
If a system like IBM API Connect, a product sold specifically to secure, govern, and centralize your most critical digital connections, can have a 9.8 rated remote authentication bypass flaw, what does that say about our reliance on these single, all-powerful gatekeepers?
The real question isn't just about patching this one bug in this one product. It's about whether the entire philosophy of centralized security control is fundamentally flawed. Maybe the future isn't about building a bigger, stronger front gate,
but about building a city with no single point of entry, more decentralized, more segmented, so that the failure of one wall doesn't bring the whole fortress down.
A 9.8 flaw in the primary gatekeeper. That's not just a bug. That is a profound digital wake-up call for the entire enterprise world.
We hope this deep dive has given you the clarity and context you need. Stay informed and stay vigilant.